Here on Earth, we all know about gravity. But what you might not realize is that depending on where you are on the planet, the strength of gravity is different. For example, up here on a mountain with all this mass under me, gravity is stronger. Water also has mass. And the Earth has a whole lot of water, it's moving around, it's changing phases. If you can track the change in gravity, you can track the change in mass, and that means you're understanding the movement of water. NASA's about to send the GRACE follow-on mission, which will continue to do just that. Let's learn about it on this episode of Crazy Engineering. Okay, everybody, we're here with Neil. He's one of the key engineers on the GRACE follow-on mission. Neil, thank you so much for joining us and answering our questions. Why do we call it GRACE follow-on?
So GRACE stands for Gravity Recovery and Climate Experiment. We're using gravity to track water motion around the planet. And the follow-on is because we've done this before and we're doing it again with 2 new satellites. The original GRACE mission was launched in 2002. They lasted for 15 years and provided amazing science for the scientists.
Both of these missions have 2 satellites. Can you explain to us why we need 2 satellites instead of just 1?
So we need 2 satellites because we're trying to measure very precise small amounts of gravity changes in the Earth. The Earth is actually lumpy when it comes to gravity. Far away from Earth, gravity is just a single number, but as you get closer to the Earth, the gravity changes because the Himalayas have a little bit more mass, certain areas have less mass. And so as a satellite is orbiting the planet, as it comes towards a large mass, like the mountains, it actually will speed up. And then as it leaves, it will slow down. And so with 2 satellites, we're able to measure the distance between the 2.
How far apart are these satellites, and just how precise do they have to have the knowledge of each other's position?
We have the satellites at 200 kilometers apart, but we're measuring down to an accuracy of a micron level, which is about 1/10 of a human hair.
That is extremely precise, but sounds like a very hard engineering problem. What's the technology that lets us do this?
We're using microwave technologies at about 30 gigahertz. Here you see one of the satellites, and 200 kilometers away is the other satellite. And what we're doing is we're firing an RF signal to the other satellite, and the other satellite's measuring that. And as you move backwards and forwards relative to the sine wave, you can measure the distance changes to the levels we need.
Neil, it's been well more than a decade since the original GRACE mission. I assume we're upgrading some of these technologies. Can you describe some of those?
Sure. Like technology advances in general, we've upgraded computer systems, we have more efficient solar cells, we have better star cameras, and like everything else in the future, we now have lasers.
Lasers, yes. What do lasers actually get for us?
So we're actually using the lasers to do the measurement between the 2 satellites. We're using RF systems from the previous missions. On top of that, we have this new technology demonstrator where we're going to fire laser beams between each other to make a more accurate measurement between the 2 satellites.
Neil, this is without a doubt one of the coolest missions we've seen. Thank you so much for answering our questions. When can we hope to see this launch?
So we're hoping to hitch a ride with SpaceX rocket later this year, and we should be collecting science data shortly after that.
All right, well, we'll certainly check that out. And everyone out there, check back soon for some more crazy engineering.